Hello and welcome. So in this lesson, I'm going to talk about fraction and decimal word problems. And we've already talked about percent word problems, and we've already used this kind of diagram to solve those kinds of problems. And it's just going to be exactly the same thing, but now instead of percents, we have fractions and decimals. So in the percent word problems, our before diagram is usually out of 100% because you usually end up solving for a lesser percent than 100% or a greater percent than 100%, but your baseline is always 100%. So in this case, our baseline is not a percent and the baseline is just one total amount of something. So let's look at this word problem here. It says, Lopez used a 5-iron, but the ball covered only 4/5 of the required distance. If she hit the ball 112 yards, what was the required distance? So the before amount, before any kind of fraction happened, was the required distance. That is the total amount here. So my before is the required distance. And I'm just going to write RD in there. And then we know that the ball covered 4/5 of that total required distance. So 4/5 is my fraction. And on the second part of my diagram, I will draw that fraction in. And because I know that 4/5 is more than a half, I'm going to make it a little bit bigger than a half of this circle for my fraction here. So I'm going to put that 4/5 over here. And I know that 4/5 of the total amount was 112 yards. So I can say that 4/5 is 112. Because I know that 4/5 of that total required distance is 112 yards. Now, for the other part of that, I can figure it out from here. Since I know part of the fraction, I can figure out what the other fraction is. So if I know that she covered 4/5 of the required distance, I also know that she did not cover 1/5 of the distance, but I don't know what that other amount of yards is because they don't tell me that in the word problem. And if I were to know the other amount of yards, if I knew how many yards she covered and how many yards she didn't cover, then I would know the total required distance. But they didn't give me that, and that's what I'm solving for. So I'm going to use what I do know to solve for that thing that I don't know. And to do that, I'm going to use one of the two equations that we learned in the beginning of the year. So we know fraction times of equals is, and we also know decimal times of equals is. And in this word problem, we're going to need the fraction one because we're working with a fraction. 4/5 of the total required distance is a fraction. So I'm going to plug what I know into this equation. And I'm going to use the part of the diagram that I already have completely solved for. So over here, I don't know anything. I don't know what that required distance is. Over here, I don't know the number of yards, so I can't use that. But over here, I know two amounts, so I'm able to plug in two different values. I know my fraction, and I know what that fraction is, so I can solve for the last part. This is the only section of the diagram where I have two pieces of information, and I have to have at least two pieces of information in order to solve for the third. So let's plug those in. My fraction is 4/5, and I don't know what the total required distance is, so I'm just going to write RD, so 4/5 of that required distance that I don't know is 112 yards because they told me that. So now I can use this to solve for that required distance. It sets it up all nice for me. So on the left, I'm going to have to multiply by the reciprocal to get rid of this fraction. On the right, I'll multiply by that same thing. And then I know that required distance is equal to 112 times 5/4, or a total of 140 yards. So I know that my total required distance is 140 yards, and I was able to solve for this whole problem. Okay, so this time I'm going to walk through a problem and not use my weird diagram, and I'm just going to try to think through this problem logically. So this one says, McAbby, I don't know, whatever his name is, guessed that the total was 30.24, but this was actually 7.2 times the total. So what was the total? So let me just think about this. He guessed that a certain amount was the total, but I know that this whole thing is actually 7.2 times the total amount. So the number that he guessed is actually 7.2 times greater than the actual total. So let's say t is the total. And I know that the total is 7.2 times that. And 7.2 times the total is equal to 30.24. So that actually set me up with a nice problem right here, where I only have to solve for one variable. I'm just solving for that t. So I didn't have to draw any fancy circles or anything. I just know that 7.2 times the total is 30.24. And then I can just solve for that like any other problem. So I would divide by the 7.2 over here, divide by 7.2 over here, and then I get total is equal to 4.2. And that is it. So that one was a pretty easy one to solve. Okay, now let's look at this one. 3/4 of the tickets had been sold, and there were 420 tickets left. So how many tickets were printed? Okay, first off, they're trying to trick us here by not writing 3/4 as a fraction. They wrote it out as words so that maybe you would miss it. So I'm just going to erase 3/4, and I'm going to rewrite that as a fraction. So 3/4 of the ticket had been sold, and there were 420 tickets left, and I need to know how many were printed to begin with. So let me just draw a box. And this box represents all of the total tickets that I started with. And 3/4 of those tickets were sold. So I'm going to split my box up into fourths and say that 3/4 were sold. How many tickets in total were printed? Okay, so I got to plug in this other number that I know here. It says there were 420 tickets left. So the 420 tickets goes in this last little box here. 420 tickets left over, and I don't know how many tickets went away. But look here. If I split a total amount of tickets into 4 equal parts, then each of these boxes is actually going to be equal to 420. So this one's 420, this one's 420, and this one's 420. So then I know how many tickets were sold. The amount that was sold was 420 times 3, which is equal to 1,260. So now that I know how many tickets were sold and how many tickets were left, I can add them up to see that my total number of tickets was 1,680. And that's it. And I think that a lot of times you can make diagrams that are a lot easier to understand than some of the ones that the textbook wants you to use, because I think that they use a lot of complicated words in them. So just try to draw it out, figure out what's going on. Draw how much you have, how many you lost, and plug in all those numbers, and then solve.